We have a group of vertebrates, the amphibians, that evolved 360 million years ago. They've been incredibly successful. They've made it through mass extinction events and better than many other vertebrates. I'm thinking in particular of things like dinosaurs. Amphibians today are really, really in bad shape. I mean, just in the last couple of decades, we've lost hundreds of species, probably extinct, and we're talking about 40% of the species that are known are probably going to disappear in my lifetime. The damage is substantial. It's more than substantial. It's catastrophic.
One of the causes of worldwide amphibian decline is a fungus called chytrid, or BD.
So these are these microscopic fungi that live in water. It infects the skin of amphibians, so it's a skin disease. And for amphibians, unlike mammals and other vertebrates, the skin is incredibly important as an organ. They breathe through their skin. Many amphibians don't even have lungs. They breathe right through their skin. And they can breathe underwater. They can breathe on land. They exchange electrolytes through their skin. So their skin is a really important organ. And what this fungus does is it basically disrupts that organ completely. It spreads over the entire skin of the animal and causes complete skin dysfunction, which eventually leads to mortality.
It's causing such massive declines all over the world, and it's just really important to understand more about BD disease dynamics and where it has spread to and where it may be causing new threats to try and conserve some of these amphibians that are threatened.
Vance, Sonia, and Dave Blackburn are in a race to stop BD. They start by looking into the past.
Because our preserved frogs in our collections still have skin, we can actually still screen those old specimens, even things that have been sitting here for 100 years, to know whether or not that specimen collected in that place at that time was infected by the pathogen.
The collections here are incredibly important because we can go back in time and do a retrospective analysis of where did this come from.
The scientists are also looking for clues to understand how some species survive BD.
The really interesting thing about this pathogen is that it doesn't affect all species equally.
Some species seem to really be affected by it, terribly affected by it. Some species seem to tolerate it, they get infected, and in some cases the infection's clear, right? So the question is, why?
How are they doing it? Is there some sort of environmental reason that the place that they live is not good for the fungus? Or is it that they're able to fight off the fungus themselves through their immune system? Or is it something else? Is it that some of them might have microbes that live, symbiotes that live on their skin that are beneficial, that protect them from these pathogens?
Sonia and Dave are looking at the microbes that live on African frogs, using swabs that Dave brought back from a recent trip to Cameroon.
I'm hoping to be able to identify groups of microbes that have the potential to have antifungal properties and could protect from BD that may be entering new populations.
Vance and his colleagues have been testing this out by bathing frogs in a microbial bath in the Sierras to help stop BD there.
What we want to do is try to sort of help out those populations by sort of bumping up their defenses, their symbiotic defenses in this case, against this invading pathogen. And we've been able to do it in a couple of cases in Sierra Nevada. How can we change an outbreak that normally would lead to extinction and then sort of switch it towards something where we might be able to get survival of the host? I want these amphibians to be around in the future. These really cool frogs and salamanders that are part of what makes our world so interesting.